Hi, my name is Robert Gendron. I'm the VP of Marketing for the Vicor Semiconductor Solutions business unit within Vicor. I'm here today to talk about making power design easy for the embedded designer, or more specifically, some of the tools that we have implemented to help design our components into a system. Now, when you're looking at designing a power type solution, the industry offers many types of tools to provide selection of products and the decision points, let's say, with products. But typically, these tools you can narrow down into really two areas. One is in the selection process, where we have simply enough selector tools. And if you go to the Vicor website, we have our own selector tool. That is, you put in the inputs you want and or the outputs, and we provide a list of components that are available. And you can optimize this list or prioritize this list by board area consumption, cost, efficiency, etc. The other type of tool widely used in the industry is that some form of validation or simulation type tool. These tools can be online, which is what we have at Vicor. They can also be downloadable. With all of these tools, you're always faced with the trade-off of the accuracy of these tools and with the time of execution or time to run the simulation to get the results that you want. And there's pros and cons to both types of tools. Here at Vicor, we've erred on the side of trying to make a tool that's online, that's extremely simple to use, that is also is optimized for speed. Again, it's a constant trade-off of speed versus the accuracy of the tool. But we try to err on the side of making a tool that can give you relevant results in a reasonable amount of time. So again, in the industry, these are two types of tools. Now, if you look at, once you've selected, let's say, components, if you look at what an engineer then does, right, as far as designing a system, most people will sketch out in a block diagram form of what their solution is. Again, it's vague at first, perhaps. It's, the inputs, the outputs, the basic components selected. What we've done is, between that selector tool and between the detailed simulation that may go on, we've created a system or tool that we call, simply enough, the whiteboard. And it really automates what most of us do already when we design a system. Okay. Now, let's back up. Regardless if you do this at a whiteboard or if you're doing this on paper, let's maybe back up and say, well, how do you go about designing a power supply type system? Well, once you've defined what you need, and again, you've used, let's say, selector tools from any of the various ones that are out there, you have a set of components. You've mapped out, in general, what your block system is, and now you need some estimates on performance, right? Maybe efficiency, thermals would be key also, let's say. So, first thing you would need to do is pull the data sheets and look at efficiency numbers. So again, data sheets from us, data sheets from whoever you have as far as the components you're looking at, this would be fairly standard. And in those data sheets, of course, you need to look at the given load that you're operating at, what is the efficiency, right? The other thing you need to look at then is that compiling those efficiency numbers to give you then, okay, what is my total efficiency or the total loads throughout the system, my total power losses throughout the system. So again, as you see here, more examples of the calculations needed for a total system. Again, more curves we need to look at as far as the power loss, and you would have to interpret off curves like this. So once you're finally done looking at the data sheets, interpreting the graphs themselves, you can get to a point on paper and identify that, what your total power loss is, what your total efficiency is. This is all I'm detailing is again, more background on what is standard practice. Now, one thing just to back up and highlight, when you do look at Vicor's data sheets and such, we're actually, when we provide our efficiency curves, our efficiency numbers and the majority of our component data is taking off of a very sophisticated ATE type system. This graph here just shows you a 3D representation of our efficiency over the input line and the line, the output, and the temperature. Okay, so the efficiency charts that you see within our data sheets are extremely accurate and represent a number of devices that have been characterized over time. And as we said, once you're done with that block diagram, calculating all the efficiencies and such, the next step you may move to is looking at some more detailed simulation, which for Vicor, we have the online simulator where you can quickly bring up a product. In this example, we're showing here a BCM, and you can alter the line, the load, and also the passes or filtering around the device, and quickly assess very specific performance parameters that you could not find, let's say, within the data sheet. But back to, as I alluded before, that whole manual process, as I briefly went through, of reviewing data sheets, calculating efficiencies, calculating power losses, we've taken that process and we've automated it. So instead of you, the user, going through and ferreting out all that information, we've created, simply enough, what we call the whiteboard. This is the actual rendition of it that's on our website. So much like you would think like a simulation tool or layout tool, we have on the left a selection of components, and then across the top you have operations to save your design, to share your design, to send your design off to either Vicor for interaction with one of our applications engineers or within your company for interaction with other engineers. So that's the basic construct of it. Now, to talk more specifically, with this whiteboard, you can put in, again, with a selection of components on the left side and the lines and loads. With placing those components in, the whiteboard, simply enough, will go off, look at the same data sheets that you would look at manually, and come back and calculate an efficiency and power loss number. Probably more importantly, it'll bring back these numbers in a time period that is not in hours, that is not even in minutes. Okay, this is an extremely high-speed tool. Now, in addition to creating your own power chain, that is in selecting components and such, if you look on the Vicor website, under our, let's say, standard application power chains that we have, and we have them divided by market, when you click one of our power chains, it actually brings up the whiteboard. So if you're starting a design, you can actually use one of our, quote, standard power chains, and then very quickly manipulate it or, again, investigate it further, as a live block diagram within the whiteboard. Very different than other manufacturers out there who typically have a flat block diagram when they show an example, let's say in the industrial space, computing space, et cetera. What we're trying to do is accelerate your design by giving you some examples and allowing you to immediately manipulate them within our whiteboard environment. So just to back up a little bit then, from as I said, here's an example where, based on the left side, we've selected some components. We've selected a PRM. We've selected a cool power isolated part, actually two isolated parts. Okay. Again, very quickly, just by clicking on the left there, you get a selection of which specific part you want. So under the pull down of PRM, you would get all the specific part numbers. You select the exact one you'd want. As I mentioned earlier, you attach to those selected parts both your line and your load information. You set any sort of operating parameters you may have around those. And then simply enough, you click Analyze. Once you click Analyze, as I mentioned, not hours, not minutes, but within seconds, you will have information pulled directly from our data sheets, pulled directly from our test information, showing you the efficiency and power loss for each of the individual components, and then, of course, for the overall system. The other thing to point out is that as you look at one component and or the system itself, not only are we giving the efficiency and power loss information, but again, both individual and for the total system, we're also providing the footprint or area consumption of the solution and the solution cost. Okay. Now, both of these are an estimate because you may not lay out the system as ideally, let's say, as we do, but the footprint consumption or footprint area number noted does give you a general idea of the size or the density that you could take advantage of using this type of system. Same as solution cost, we're using our standard pricing. So pricing may vary depending on the quantities involved. Now you can also adjust, you can make changes on the fly with this. You can also change the operating temperature of your system. And again, by changing the operating temperature here, that will affect the information that's being pulled as far as the performance goes. Again, right now with our efficiency and power loss numbers that we're showing. Okay. So in this example here, we increased the temperature and just showing that there was a bump in both in the change, I should say, in the efficiency and power loss. So in addition to, like I said, the 3-chip solution we just showed, the solutions can grow quite dramatically. In this one here, we're showing 8 devices all being powered together, multiple outputs. And again, the solution time or time to run this type of a whiteboard is within seconds, not minutes, not hours. This is not, as I mentioned, a full-blown simulation. What this is an intermediate step between the selector tool and full simulation. It gives the engineer, it gives yourself a tool to quickly evaluate performance and quickly select different components to build your system. Now, in addition to the selector tool, in addition to the standard block diagrams we may have, in addition to building your own block diagram from scratch, our selector tool is expanding to include multiple output type configurations. So today, or I should say historically, our selector tool allowed it for an input and an output and would provide solutions. Now if you look at our selector tool, you will have the option of selecting multiple outputs for a single line, and this will provide a solution. Okay. So you then can click, and sorry I maybe moved too fast, then you can then click on, based on the selector tool output that was provided, you can then click on that solution shown in the selector tool, and it will bring up the whiteboard and show you the entire solution here. So based on just your input and output criteria, we can generate a whiteboard within seconds. So in summary, I try to quickly show you that what typically is done in a more manual process between, once I should say, two types of products are selected and not going to full simulation. That is, when someone is sketching out their type of system, we have taken all of our information that sits behind our data sheets and such, and are providing that in an online tool, a GUI if you want to call it, but a tool that automates what someone would have to do manually. And this really allows for the user to quickly design a system or have a system suggested to them that they can redesign. It allows for them, given the speed of the system, to manipulate it in different ways to truly optimize it to exactly what they want. And that's why it is not a simulator and it is not a selector tool. It's truly a bridge-type tool between the two that we have. So I encourage you to try the tool yourself. Again, it is what's called the Vicor whiteboard. You'll see it utilized all over our website. But please, again, I encourage you to use it, and I thank you for your time.